Hello everyone and welcome to my channel Chemistry by Miss Nidhi Banga. Today we will be talking about competency focused practice questions released by CBSE. This is chapter 1 and let's get started. Question 1. Which of the following is an example of simple displacement or single displacement? Let's look at the options. The first one is electrolysis of water. Electrolysis, as the name suggests, is lysis by means of electricity. So it's breaking water with the help of electricity. So clearly it's it's a decomposition reaction, not simple displacement. So this can't be the answer. Burning of methane. Burning of anything is basically its reaction with oxygen. So methane's reaction with oxygen is combustion reaction. Combustion is not simple displacement. So again, not the answer. Reaction of a metal with an acid. Let's write down this reaction. Metal plus HX, HX being the acid. We know that metals, when react with acid, they give hydrogen gas and form a salt with the negative part of the acid. Let's balance it. Okay. Okay. So, all right. So this reaction, if you look at this reaction, it's as if the metal has displaced hydrogen from its salt solution, right? And that's how it is releasing hydrogen. Mind you, not every metal can displace hydrogen from acid. Only the metals which are above hydrogen in the reactivity series, like copper won't give this reaction, silver won't give this reaction because they are below hydrogen in the reactivity series, right? But those which ones are above hydrogen in reactivity series, they would definitely release hydrogen by displacing hydrogen from the acid. So yes, this is a simple displacement or single displacement. Okay, as you can see, the metal has displaced hydrogen, right? So this is the answer. But still, let's look at the fourth option. The reaction of two salt solution to form precipitate, AB plus CD, gives you AD plus CB. Okay, this is double displacement reaction. Okay, here the two salt solutions are exchanging ions. So it's a double displacement, not a single or simple displacement. So our answer is third. Okay. Now, second question. Which of the following is a necessary condition for all chemical reactions? Let's look at the options. The reactants should be in the same state. Not compulsory. Because if you look at the reaction of iron with steam, iron is solid, steam is gaseous. They still react. So they don't have to be in the same state. So first cannot be the answer. Energy should be supplied to the reactants. Again, false. Because plenty of reactions occur at room temperature without providing any energy. So this is also wrong. The reactants should be at the same temperature. Again, not compulsory because so many times metals react with hot water, right? Or steam, where the metal is very much at the room temperature, but hot water or steam are obviously not at room temperature. So their temperatures are not same. So this is also not compulsory. Fourth, there should be a physical contact between reactants. Absolutely. Unless the reactant would collide with each other, how would they form the products? It's necessary for all the reactants to collide with each other so as to form the products. Okay, so our option is definitely fourth. Question 3. Given below is the balanced chemical equation for thermal decomposition of lead nitrate. Which of the following information does the coefficient of PbO and NO2 in the equation 2 and 4 respectively tell us? Okay, so it's asking that what does this 2 and what does this 4 tell us? It's definitely the ratio of the number of moles produced by the two substances. Okay, or if it had been number of molecules, that would also have been correct. Okay, that would also have been correct, but here that option is not there. So this is how we read an equation. 2 moles of lead nitrate decompose to give you 2 moles of lead oxide, 4 moles of nitrogen dioxide, and 1 mole of oxygen. Or this equation can also be read as 2 molecules of lead nitrate decompose to give you 2 molecules of lead oxide, 4 molecules of nitrogen dioxide, and 1 molecule of oxygen. Okay, so this is our correct answer. Moving on. Okay, this is clearly electrolysis of water. As you can see, at anode, oxygen is being produced. At cathode, hydrogen is being produced. You can see the ratio of the volumes produced. Oxygen is half of hydrogen in terms of volumes and in terms of moles, right? So this is electrolysis. Let's see what the question is. What type of reaction is this? Now, electrolysis is given in the question, so they're not asking that. They're asking what kind of reaction is this, like combination, decomposition, oxidation, redox or displacement or double displacement. This is clearly decomposition, because here, as we know, water is being decomposed to give you hydrogen and oxygen. Okay, let's balance it here. Okay, so since water is decomposing, this is decomposition. Explain why this is an example of endothermic reaction. As we can see, that energy is being provided. Okay, so this energy, unless you provide this energy, the reaction won't happen. If you have a glass of water, it doesn't just break into hydrogen and oxygen on its own, not unless you connect it in a circuit and provide energy, right? So the it's an example of endothermic reaction, because unless the electricity is supplied, the reaction would not occur. Okay, next. The test tube containing hydrogen is removed carefully from the apparatus. A lit matchstick is brought near to the mouth of this test tube. The gas burns with an explosive pop sound. A classic test for hydrogen. Write the balance chemical equation for this reaction and indicate whether energy is absorbed or released. So this is the balanced chemical equation, and as we have discussed, energy is needed. So it's an endothermic reaction. Okay, moving on. Okay, 8 identical iron blocks are placed on the ground in 2 arrangements, X and Y. So basically they are identical iron blocks. They have same surface area, but they are placed in different ways. The block arrangements are kept moist by sprinkling water every few hours. Which arrangement is likely to gather more rust after 10 days? Okay, so to start with, they had the same surface area, but now that they are kept in 2 different arrangements, the exposed surface area is different. If you look at it, it's very clear that Y has the most exposed surface area. If it doesn't make sense like right away, consider this. In case of Y, the hidden surface area is less. In case of X, the hidden surface area is more. In case of X, since the hidden surface area is more, the exposed surface area is less. And since rusting is a surface phenomena, okay, rusting is a surface phenomena. It occurs on the surface. Surface, more rusting. So obviously, Y will gather more rust after 10 days. Okay, moving on. Question number 6. The following chemical reaction does not represent a chemical reaction that can take place. State what needs to be changed in the equation for it to represent the correct equation with reaction between iron and water. We know that iron does not react with cold water or hot water. It reacts with steam. And this is definitely not steam. So this needs to be changed. This needs to become gas. Okay? Everything else is right. All right. Moving on to question number 7. Trupti mixes an aqueous solution of sodium sulfate and aqueous solution of cuprous or copper chloride, cupric chloride. Will this reaction lead to a double displacement reaction? Justify your answer. Okay. Let's see what would have happened had they reacted. You have sodium sulfate and copper 2 chloride. Had the double displacement reaction occurred, it would have given you NaCl and copper sulfate. Okay, simple exchange of ions. Let's balance the equation. Yep, balanced. Now, if you look at it, if you pay attention, you know that the two products that are formed, NaCl, your regular salt, and copper sulfate, this also you know. These two, as we know, are soluble in water. They are soluble in water. So they would not form an insoluble precipitate. Okay, so all the ions would remain in the solution. Okay, so double displacement reaction would not occur. All right, next. Dilip was comparing combination reaction with decomposition reaction. Which class of chemical substances may be the product of a decomposition but not a product of combination reaction? Okay, so if we have to write combination reaction, we can write it as this. 2A plus B gives you A to B. Okay, that would be combination. Decomposition would be A to B giving you 2A plus B. Okay, this is decomposition and this is combination. Okay, now the question is which class of chemical substances? Chemical substances, that means pure substances, have two classes, elements or compounds. You know this from your grade 9. So which of the two can be product of decomposition but not a product of combination? What is the product of decomposition here? Elements. And elements cannot be product of combination. Okay, they can be reactant of combination, but they definitely cannot be product of combination. Combination reaction by definition occurs when two simpler substances combine together to form a more complex substance. An element is not a complex substance, it's the simplest of substances, right? Therefore, the answer is element. Elements can be product of decomposition but definitely not a product of combination reaction. Moving on, write the balanced chemical equation of any one reaction that cannot be classified as combination, decomposition, simple displacement or double displacement. Now here, what else is not given? Redox is not given. What else can you write? You can write even combustion. See, if we take methane and combine it with oxygen, it gives you carbon dioxide and water. It does not fall into any of these categories, right? So this is one of those reactions. Let's move on. Last question for the day. Tina finds a paper covered with white substance in chemistry lab. She keeps the paper near the window, that means near the light, and comes back to pick it up after 5 hours. She notices that the white substance has turned gray. There's only one reaction in your syllabus where white substance turns gray, and that is photodecomposition of silver salts, right? Let's see what are the questions. What could be the most likely substance on the paper that Tina found? Like I said, it has to be a silver salt. So you can write silver chloride or silver bromide or even silver nitrate. Okay, they are silver salts, they are photosensitive, they decompose upon upon reaction with sunlight, and they decompose into silver and the other substance. The substance changed from white to gray. Write the chemical equation for this reaction. Okay, let's see. Silver chloride upon being photodecomposed, or let's make it simple. Let's write sunlight. Okay, upon kept in when it's kept in sunlight, it decomposes into silver, metallic silver, elemental silver, and chlorine gas. Oh, I'm sorry, I've made a mistake here. It's AgCl, not AgCl2. Okay, valency of silver is 1, and this is now Cl2. So this is how we balance. Okay, you can write the same reaction with AgBr also. State one application of this property of the substance seen in daily life. We all know that there's only one application, black and white photography. So that's it for the day. We have discussed all 10 questions. I hope they made sense. Thank you for watching. And if you like the video, if it helped you in any way, please subscribe, like, and share. Thank you.